Ignition sequence start. 5, 4, 3, 2, 1, 0. All engine running. We have a liftoff. Liftoff of Apollo 11.
We have someone leading this revolution right here in Australia. That is Kiriti Rambhatla, founder of Metakosmos, pioneering next-generation spacesuit technology.
One fine day, I just happened to be a visitor at NASA Ames Research Center, and I was just looking at things, and I was told that the spacesuits have been very expensive, but they're a very critical component in human space exploration. But then I've also been looking at a lot of sci-fi films and what they do for designing these superhero costumes and stuff, so technically understanding what happens behind the scenes.
The moment you took up Metakosmos, what was your whole idea?
Insane amounts of money being invested into building these things, but very limited suits in the market. That's where we believed there was an opportunity for us to build commercial suits, so that would help people train more astronauts.
Because spacesuits aren't just clothing, they are essentially spacecrafts worn by humans.
Using AI and machine learning, and this also goes in the direction of all the medical grade stuff that you could bring in, because we are tracking all the incredible fitness tracking that's happening in the world of wearable devices, and where AI is going in that space. So this is, you could say, a full body Fitbit in that sense. The focus for us from the beginning was, can we create a market for spacesuits? And that's how it began, because we just don't see that today.
When you're not building systems for space, how do you relax or recharge?
Movies. I love graphic novels. I watch a lot of sci-fi work that people do. I love the entire behind-the-scenes process of how filmmaking is done.
This year's award goes to Metakosmos.
Hey all, welcome back to Spacefront Conversation. Today we are diving into an often overlooked but fascinating part of human spaceflight. Those are spacesuits. Beyond rockets and satellites, spacesuits represent the gateway between humans and hostile environment of space. And to help us unpack this, we have someone leading this revolution right here in Australia. That is Kiriti Rambhatla, founder of Metakosmos, pioneering next-generation spacesuit technology. Welcome, Kiriti.
Thank you. Thank you for having me.
So before we dive into the exciting technologies Metakosmos is building, I would love to start with your journey. What first drew you to human spaceflight and the idea of designing spacesuit?
I've had a start in technology, so I've been to an engineering school in Canada, and at the time, like everyone else, I was fascinated with space and aerospace sciences and all of that. So I was a student member of the Canadian Aeronautics and Space Institute. So that was my start in trying to understand a bit about what happens in the industry and how things function, basically. But then there was no SpaceX. When I graduated, very limited opportunities to get into the field. In fact, my first internship was an aircraft maintenance engineer. So that's how I got a start in the aerospace vertical. And then I've been in the verticals of technology, a bit of media and entertainment, and then sort of like emerging technologies. And one fine day, I just happened to be a visitor at NASA Ames Research Center. And I was just looking at things, and I was told that the spacesuits have been very expensive, but they're a very critical component in human space exploration. So that's when the thought began. But then I've also been looking at a lot of sci-fi films and what they do for designing these superhero costumes and stuff, so technically understanding what happens behind the scenes. That's how I happened to merge both. I thought there was an opportunity. I was reading what SpaceX was doing, and then COVID happened, and I decided to take a plunge, and yeah, here we are.
Yeah, wow, it's fascinating, and how a single spark can evolve into a whole career point. Yeah, moving on to, I believe Metakosmos is such a unique venture. Yeah, now what was the spark, or The moment you took up Metakosmos, what was your whole idea?
So I think we started off because I've also been to business school, so I understand a bit about the basics of business and things like that. So I believed that there was an opportunity to essentially provide commercial and accessible spacesuits, and that's one of the bottlenecks in the entire equation of human spaceflight, because the training infrastructure is very expensive. You probably would have seen a lot of news articles saying thousands of people applied to be in the astronaut cohort and barely a handful make it. Yes. And one of the reasons is also because they don't have infrastructure to train a lot of people. Yes. And the core components of those infrastructure are related to spacesuits. And we realized that there is insane amounts of money being invested into building these things, but very limited suits in the market. That's where we believed there was an opportunity for us to build commercial suits. So that would help people train more astronauts, would give people a chance to get into more suits. Mm-hmm. And that's how we thought there was a business model for it. And we started the company with that in mind.
It's really amazing to see how vision turned into action. Yeah. So a vision for Metakosmos is excelling at the edges of extremes. What does it mean in practical terms?
Certainly. So when we started, like any other startup, we went through a bunch of incubation programs where they take you through how to build your business in a structured format. So the incubation program we've been in, D-Start Ignite, basically was run in collaboration with the Department of Defense and CSIRO. So that's where we got our start for human performance, and why it is an incredibly important factor that you need to consider, specifically when you put them in extreme conditions like land, sea, air, along with space. And we understood that there was a lot of research happening in that space, but there weren't many commercial avenues or products that people could get their hands on. So that's how we started the whole process of understanding human performance in extreme conditions. And what it actually means is, how do you protect people when they are in the extremes? I mean, you understand it because you're an aerospace engineer. If you're flying a fighter jet plane for testing purposes at Mach 3 or Mach 5, or you're training to be these pilots, or you're doing deep sea diving, all of these are not natural conditions for humans. So at that point, you need to be protected. You need to be at the top of your cognitive function. And all these things come into essentially the human performance aspect. And now what we're trying to do is making sure we just don't protect people, but we make sure that they thrive in those environments. So that's basically the whole point around human performance and excelling at the edge of extremes.
Yeah, that phrase really captures attention. But of course, vision is tested when challenges comes up. So what were some of the early challenges in building human-rated systems for space?
I think there's two aspects. I would broadly put them in the human-related things, and then you have all the technology-related stuff. So on the human side, it's very hard to find people who can design spacesuits in the market. You can't just go into the market on, like, say, other industries and you go, I need a chemical engineer or I need a software engineer, and you find a talent pool that you could sort of engage with. The human side was very difficult because there were very limited institutions that you could talk to and sort of get support from. On the technology side, obviously, there's other challenges related to building it, because there's very limited experience in the market, supply chains that could help you build these things. So those were the two most important challenges for us to balance in the early days.
Yeah, I think overcoming those barriers shows real perseverance. But I'm curious to know, were there any moments in your life where you almost gave up on this path, and what kept you going?
I think the first time when you start, you have to get used to getting rejected, and that's a part of this game. So you'd have to go pitch your idea. And the initial phase was a little hard when you were getting turned down, because people don't see a viable business model in a business like this. And so that was the toughest part. And the early rejections would make us second guess things and think about whether we were doing the right thing. But that was the phase where it felt like maybe we should sort of reconsider our decisions. But once we realized that that is something that happens to everybody and you have to go through that process, it was pretty easy from there on. And yeah, we don't have those thoughts now anymore, thankfully. But what we'd love to do next is sort of like, deal with the rejection in a way that it helps us.
It's really remarkable. And it makes me wonder how your roots shaped this strength as well. And now let's talk about the technology itself. Because spacesuits aren't just clothing. They are essentially spacecrafts worn by humans. So from aerospace perspective, systems like sensor suits remind me of how we monitor astronaut vitals during EVA. But you have brought that precision to everyday use. Can you walk us through one of your current human spaceflight projects?
Certainly. So as you mentioned, it's a spacecraft. It's a mini spacecraft that needs to protect the human. So there are a lot of aspects to designing spacesuits, and it extends across the entire life cycle of designing the engineering behind what goes into the suit, starting with materials. You've got technical textiles that you need to deal with, and the entire human aspect of the biomechanics of how a user would sort of experience the suit inside. And there are things related to actually tracking that in the form of a telemetry. So what we're now trying to do basically in the EVA process is understand, can we do a lot of real-time engagement with the person inside the suit when they're in extreme environments, so we could ensure that if they need support, because there's going to be all these other issues, so they may not be able to focus on the task at hand, so you need to give them the right support. And if you could do that real time, I think that would be incredible, which is happening in a way, but we're building on top of what's already been done and make it a 10x improvement. So there are projects around a bit of telemetry, the mobility of the person, and life support systems that we're really invested in.
Yeah, that's exciting. And let's zoom on in what systems are most critical for survival in space that Metakosmos focuses on.
Yeah, like I touched upon in the previous point, I think the most important one would be life support systems. And this is related to your oxygen and scrubbing of CO2 and protecting the human from space radiation and really fast-moving objects like micrometeoroids and other things. So we're focusing on making sure that there is a longevity associated with the life support system, not because we'd want them to work inside these suits for 24 hours, but in the event of an emergency, you could still operate well within, the boundaries of what's acceptable. Mm-hmm. So we're investing a lot of time on the life support side of things and ensuring that we could inform the mission control centers real time about the amount of radiation that would be hitting the suit when they're exposed to these conditions. I think those are the two most important things that we're currently sort of investigating.
Yeah. It's wild to think about all the invisible systems working just to keep one human alive. So let's talk on the Metakosmos products and the technologies. When I first saw the sensor suit, I was really amazed at how it blends biology and engineering. So sensor suits acts like second skin. How do you integrate injury protection, thermal management, and biomarkers tracking all in one system?
So if you look at the legacy spacesuits, there's always a need for a base layer that does all of the thermal management for the suited user. So in our case, we decided to build a suit that could have parallel applications in other industries as well. So this sensor suit is the base layer, as you mentioned, that would play the role of injury protection, biomarker tracking, and all the telemetry access. And these injury protection mechanisms have been designed with the research that was previously done on the areas that are vulnerable for injuries, for instance. So we make sure that all the hotspots in your body that are prone to injury are protected through the sensor suit. At the same time, keeping a good thermal management profile helps you with energy expenditure and fatigue and all these other aspects. So the sensor suit is meant to be the real beating heart of the system in a way, because it will keep you in a very comfortable position to be able to go about your mission.
Yeah. It's amazing to think of clothing that not only protects, but actively supports the body in real time. And what type of biomarkers can sensor suit currently monitor, and how could this evolve for astronauts in long duration missions?
So when we started designing the entire intelligence behind what we could gather from the suit, I think we went with what was already available in the industry in terms of what NASA had already published, based on their understanding of the astronauts who've been exposed to long duration missions. Through that, I think musculoskeletal systems have been at the top because they face a lot of impact around the musculoskeletal side of things. And then you've got the cognitive aspects of the person who's in microgravity. So we're broadly categorizing these things, and we work with medical institutions basically to extract this information in a non-invasive way onto the suit. And for long duration missions, obviously you would need a consistent stream of data that you could access, not just during the flight, but also pre-flight conditions, because you'd want to get a good baseline of how the astronauts' performance was before they got exposed to the real environment. So we make sure we connect all those dots.
I think that really opens up a lot of possibilities. If I can ask, did you get a chance to talk to Sunita Williams and Williams when they returned from space? Because I think they have spent quite long time than expected in the space.
Not Senator Williams, but we've spoken to quite a few astronauts, both career astronauts and commercial astronauts, about their experience in microgravity and where some of the pain points were as far as suits were concerned. Yeah. And I think it's one thing to just see the videos and do your research, and it's another thing to actually talk to people who experienced it and learn from their perspective and what they'd like to see. So mostly astronauts have mentioned that they'd love to have more comfortable suits and suits that are possibly easy to sort of access as well, because a lot of them would love to keep a suit for themselves as a souvenir. But currently, these are very expensive pieces of equipment that are limited in their production and also not easy to operate in.
Do you see applications of sensor suit beyond spaceflight, like defense, sports, or healthcare?
Well, there have been conversations in that direction because there is a lot of work happening in those areas that relates to something similar to what we're doing. The core application is obviously intended for space, but we're certainly open to experimenting with use cases across land, sea, air, and space. And defense, I think, would definitely benefit from something like this, given all the extreme environment training that they would do, along with industries like oil and gas and other sectors where you have users being exposed to chemical, biological, radioactive, nuclear environments. I think there is some potential in those areas.
Yeah, it shows how space technology can ripple back into everyday life. And Cosmosuit is described as on multi-environment platform. How does it adapt across space, lunar, underwater, or terrestrial extremes?
Yep. So the whole point behind us designing the exosuit, the outer layer, to be modular is to ensure there is a lot of reusability built into these platforms, so you could replace components that are wearing out. In the process, we've designed an architecture that could be adapted for multiple environments. There would be some changes, but I would say about 60 to 70% of the exosuit architecture stays consistent, and the remaining 30 to 40% would change based on the environment people are being exposed to.
It really clicks. The Cosmosuit isn't just a suit. It's a wearable spacecraft, as we said before. So how do you engineer modularity without compromising safety in any environment?
Again, because we put humans inside our product, safety is the number one priority for us. So we ensure that everything is being designed to human-rated systems, and that's a very long roadmap. So you have to go through essentially a lot of stages of regulatory compliance, which is built into our entire process from day one. Yeah. So it's not like we're building a product and then we decided to go for a compliance certification. The certification begins when we start at a conceptual level, and it goes all the way down to maintenance. So that's how we're bringing that lens of safety to this whole process.
It's impressive that how one system can, adapt across land, sea, water, and space. So what materials and design innovations make Cosmosuit both lightweight and durable?
Certainly. I think there's a lot that you could look at across the spectrum without touching too many confidential points, I could tell you there's lots of innovation happening around the materials, the textiles, and the whole process of how we bring it together. There's a lot of trade knowledge that we bring into this process to ensure that the lightweight specifications are met, and at the same time, you're not compromising on aspects related to the safety of the person inside it. So there's quite a bit that happens in the world of designing new materials, in some cases even developing new science, because those domains have not evolved in the last 50 or 60 years. So there's a lot happening in those areas.
Yeah, it sounds like material science is just as important as engineering. How do you test adaptability in real-world scenarios before deploying to more extreme environments like the moon or Mars?
That's a great question. I don't think there's an analog for space environments. I mean, you could do thermal vacuum tests, you could do all these simulated stuff. I think the closest that you could get to things would be underwater testing. You probably would have seen the giant pool at NASA where astronauts are training inside the neutral buoyancy lab. So there's opportunities like that that you could use to establish the credibility of your designs. But there is a very well-articulated pathway for running a lot of tests, but these tests are very specific to the components that you're referring to. So every component in the suit has its own dedicated list of tests that you'd have to put it through before you can make your product space-grade or space-worthy.
Yeah, I think this rigorous testing will give valuable insights. And moving on to Kernel 360. Kernel 360 seems like the brain behind the suit. How does it monitor, process, and optimize human performance?
Yeah, so we've fundamentally looked at what's happening in the world of real-time data that's being captured across all the industries. And then having this exposure to aerospace systems, we looked at what the flight test instrumentation industry does in terms of capturing a ton of data, or even jet engines for that matter. If you look at the way they're being tested, there's a very rigorous process that they go through. But when you come to the world of space and spacesuits specifically, there's a gap in that space where you need to run some of these tests and understand the performance of the suit in different conditions. Yeah. So we decided to essentially create Kernel 360 as a platform where you could store the performance of the suit for its life cycle. So whether you're in a pre-flight training program, you're actually in orbit, or you're in a post-flight conditioning program for your musculoskeletal health, you could connect all of your performance intelligence onto Kernel 360. And that gives you a unified single source of truth across that chain. And that's why we decided to design it and make it a part of the entire ecosystem or platform, so to speak.
Yeah, the way you have linked human performance data with suits operations through Kernel 360 almost sounds like an onboard AI for the entire body. How does Kernel 360 integrate with Sensor Suit and Cosmos Suit to create a full human machine ecosystem?
I think when we looked at all this sci-fi stuff going around, I think the Iron Man references are pretty critical here, because when you look at Jarvis and everything that was happening inside the suit, that was the inspiration we had initially when we embarked on that journey of, if you just build suits, they're just treated as commodities in the industry currently. So people just get inside them, go about their job, and then they're disposed or probably used for their shelf life. But we thought you got to make them intelligence gathering tools. And that's when the whole idea behind connecting the products came up, and we decided to make that a connected ecosystem. So now you've got one digital source that could connect to all sorts of components in the suit and generate the kind of operational intelligence that you would need to enhance your process as well as the use cases that you would be engaging in.
Yeah, that ecosystem approach makes the suit more than hardware. It becomes a living system. What role does AI or predictive analytics play in Kernel 360 for anticipating risks like fatigue, dehydration, or injury?
Yeah, I think AI is a big part of everything we do in the digital space. So it's hard to ignore all the artificial intelligence, machine learning developments that are happening in that space. So we use a lot of that in the areas where there is a dearth of information. So you could create a lot of synthetic data that you could apply to places where you can't really generate real-time statistically relevant data. And you could use that to train your systems to sort of build them for that next generation deployment. So AI and ML are engaged in the entire process, right from design to production to maintenance as well in the future. So we're making sure that there is a connectivity, as I said, in the backend that drives all the downstream applications for us using AI and machine learning. And this also goes in the direction of all the medical grade stuff that you could bring in, because we are tracking all the incredible fitness tracking that's happening in the world of wearable devices and where AI is going in that space. So this is, you could say, a full body Fitbit in that sense.
Yeah. What's fascinating to me as an engineer is how Kernel 360 can serve as a human mission control system, similar to how spacecraft telemetry is handled. Could Kernel 360 become a platform for training or mission simulation beyond real-time monitoring?
Yes, certainly. So we have been talking to a lot of target user groups, starting with students and academic researchers to people in the industry to understand where there is utility for a tool like this. And there's other industries as well where they could benefit from monitoring groups of people when they go out on a certain mission, and you could sort of apply a tool like this to those operations to make sure you're tracking the safety of the people in that operation. At the same time, it could help you train before you get onto the real equipment, because sometimes this equipment is really expensive. So before you have people jumping into the equipment, you could use these simulations or training modules that we've built on Kernel 360 to get that experience to people.
Yeah, that would make it not just a safety system, but a tool for learning and preparing the next generation of explorers. Spacesuits are essential for human survival, but they remain incredibly expensive. Unlike many technologies that get cheaper over time, what do you think that is, and what would it take to make them more affordable?
Oh, that's our entire business thesis, really. We believe that over the last few decades, there was a certain model in which the countries operated in to produce their spacesuits. For achieving a certain model, they had to engage with, let's just say, 20 to 30 different companies that brought together different components, and that leads to a certain design restriction, leading to maybe over-engineering in some cases or bloated budgets. So that led to things being very limited in the market, and there was never an incentive, we realized, for people to innovate in the space because they were answering a call or going after a tender or a contract. And so the focus for us from the beginning was, can we create a market for spacesuits? And that's how it began, because we just don't see that today. And that's what leads to this thing being very limited in its production run and being bespoke in a lot of cases. And so that's what leads to this being very expensive in the first place. And it takes a lot of research and development as well. So the industry of spacesuits, if you were to call it that way, it's been around for almost 6 or 7 decades. And so they've done a lot of work on it, but it's never been done for mass production. And that's what led to the cost, going in the opposite direction. So we call that a positive correlation. Like you mentioned, the more of something that you produce, the less it should cost. But in the world of spacesuits, it is turning out to be the exact opposite. It's turning out to be more expensive every time they're producing a limited number of pieces. So what we're saying now is you've got to fix that equation, and that could be done through certain technical aspects related to how you design and produce them in the first place. So we believe an original equipment manufacturing approach, like you would have in the world of automobiles or aircrafts, is very much needed in the world of spacesuits to drive that cost down.
So are there any engineering materials like smart fabrics or metamaterials that you are currently experimenting with for spacesuits?
So the way we sort of go about our engineering is we obviously have stuff that's already state of the art. So we get access to that from the market. And we also draw a horizon or a roadmap for what's going to be in the market in the next 3 to 5 to 7 years. We're obviously not experts in all the areas that we're trying to bring together. So we do work with some of the specialists in certain domains to ensure that we get that sort of tech specifically materials, is a part of our design process. So we invest a lot of time in incubating a supply chain that's capable of producing next generation stuff in those specific domains for sure. And that goes across sensors, materials, fabrics, and even production methods, very novel production methods.
So given this, how do you approach sustainability and resource efficiency in human spaceflight systems?
So when you talk about human spaceflight, obviously there's lots of things associated with it. Even rockets are part of that equation. So we're focused on the spacesuit side of things and the life support systems that would go inside it. Sustainability is a very big point for us because we're trying to bring in modularity, and that's associated with the whole circular conversation. So we're looking at using recycled plastic maybe, and could that be a part of this design process? Or are there things that we could do for the materials or textiles that are already available in the market in the recycling ecosystem that could be a part of this equation? So if you're trying to go down the route of sustainability early on, you'd be able to fix a few areas related to modularity. But sustainability is definitely at the top of it. And then you have to manage risk at every stage. So that's a part of the process for us.
Yeah, that's an important perspective. How do you test or validate Cosmosuit systems before actual deployment?
Oh, that's an area we've invested a lot of time. And that's a way to differentiate conceptual work from the real suits that go into or that are certified to be flown into space. So there's an ecosystem of testing standards that have been developed at NASA, ESA or JAXA, or even ISRO right now. They all have certain standards to which you need to adhere to essentially test your suits. And they go across a host of different categories, as I mentioned early on, like thermal vacuum or radiation or temperatures. And, you could do a whole host of tests on off-gassing and neutral buoyancy. So you could go on. And if you were to really look at the standards that have been defined specifically for spacesuits, I'd be surprised if it's not close to 200 to 300 different kinds of tests when you take everything into consideration. So you'd have to make sure that you're through all these tests and what's expected as a bare minimum performance for the suit before it goes into space. But in most cases, you'd want to be performing really well on those tests before you become space grade.
That's rigorous. Yeah. I wonder how you combine the technology and human needs in those solutions. And how do AI, automation, and human factors combine in your solutions?
Yeah, part of the challenge in a way, and also the exciting part of designing what we're designing is the multidisciplinary nature of it. So you can't just do materials or textiles or production. You got to be able to bring all sorts of technologies together to build this system. And I think at the heart of it is human factors or the ergonomics or all things associated with the experience of the user inside the suit. So human factors forms a core aspect of our product design. And that's where the industrial designers and the team look at various aspects related to your experience and your interaction with what's happening inside the suit. And that's a tricky one because human beings are all very different and everyone could have a unique experience inside the suit. And largely to date, I think this has been captured in a very qualitative way. And we're using AI now to see if we could standardize and build an objective framework for understanding the nature of human factors inside our suits so we could make it a little more efficient as it moves along its generational pathway design.
It's impressive how multidisciplinary it is. I think innovation is at the heart of Metakosmos. How do you foster a culture and creativity and breakthrough thinking within your team?
Certainly. So over the last 2 decades, I've been involved in a lot of innovation in the tech space. Not just as a buzzword, but we were really trying to understand where we could innovate that, would have a business impact. And at the same time, you make a contribution to the industry as a whole, to the vertical of human spaceflight. So we have taken that approach from day one where we wanted people to bring in a disruptive approach to the way things are done. At the same time, it's a dichotomy because you want to operate in the realm of compliance and standards. At the same time, you want to be a little disruptive. So what we do is we take a problem statement and we explore all possible design solutions in a space, and we go after those rather than sticking to the legacy models. And that gives us a bit of a wiggle room to innovate. And that's what most of the functions are doing right now, right from design to engineering, production, all the way down to testing as well. So we're creating a lot of innovative pathways for people inside the team to explore different models and see how innovative they could be, not just in a theoretical sense, but in the sense they could have an impact on the industry and the supply chain.
That's inspiring. Innovation really thrives when the mission connects deeply with the purpose. And can you tell us about your patent pending innovations and what makes Cosmos suit different from legacy suits?
So that's a great question. I think the whole thought behind us patenting some of the work that we have started doing was understanding what generation of spacesuits are we currently looking at? Because when we look at fighter jets or all the other industries, they have a way to assess the generation of the next product that's coming out. So you probably would have heard about the American B-2 bomber aircrafts that were in the skies recently, and people are talking about 6th generation and 7th generation. So we understood the legacy spacesuits. We've done a lot of deep research on what came before us, like the Russian spacesuits, the American spacesuits, and now the Chinese. And when we say spacesuits, we'd like to draw the distinction between the IVA suits and the EVA suits, and we're looking at the EVA suits. And we believe we're designing the 6th generation of spacesuits. So that means certain capabilities that are previously non-existent on the suits are being embedded, and certain capabilities related to the production aspects as well, so that it can truly sustain the novelty that's being brought in, and at the same time, it pushes the envelope of what can be done in the world of spacesuits. So that's where we're kind of like, protecting some of these technologies through patents, trademarks, and copyrights and all of that.
Yeah. Given this, are there any partnerships with international space agencies or companies that are particularly exciting to you?
Certainly. So when we first started, obviously we worked with incubation programs that had the support of the government, the space agency here locally. And then we have a lot of industry partnerships with people who work in the aerospace and defense sector, who are involved at the cutting edge or the bleeding edge of technology. And we consistently, engage with ecosystem partners. And these could be space agencies or manufacturers or end users like astronauts who could be the beneficiaries of this technology. So there's a lot in the works, a few under wraps, but yeah, we keep exploring these things on a daily basis.
Yeah, partnerships can accelerate progress, what I believe is. And looking ahead, what future tech trends in human spaceflight excites you the most?
More than future, I think recently I was very excited when the mission for SpaceX Polaris Dawn happened. That was the first commercial spacewalk. So we saw how a commercial astronaut on SpaceX could actually do an EVA. And this was entirely done in the private sector, which I thought was incredible because it would open a lot of doors for companies like ours to produce a lot more suits, because a lot more people would want to go and experience microgravity like that. I think it would be very interesting to have an ecosystem like electric vehicles for spacesuits. So you have a lot of people competing like the BYDs and the Teslas. And we'd love to see a similar trend in the world of spacesuits where you need competition, you need healthy competition to push the technology further. And that's one of the reasons why these things have been so expensive over the years, very limited production. So I'd love to see a trend where there is more availability for you in the market. Could you imagine just having one brand of clothing that you'd have to work with? So we're saying you need more. I think that's a good trend to look forward to.
Yeah, it's fascinating to imagine what kind of revolution it can bring in. Let's talk about, what was that aha moment that led you to find Metakosmos? Can you give overview of the types of systems Metakosmos is creating? For example, it might be life support or habitat or mobility.
First, to start with the aha moment, I think I got a sci-fi space cop suit made for myself I think around COVID times. I just wanted to get one made for myself. And when I was getting inside it, I realized it was an incredibly complicated process. It's not easy to work inside those things. That's when I realized that there's lots of problems that you could solve in that domain, really. So those were some aha moments early on. But specifically, we're focusing on what we call mobility inside the suit. So a lot of times, again, you would notice people making generic statements like, we're more efficient or we're more advanced, but we want to be very specific where we say we can create more range of motion in the upper torso, or you're going to have more degrees of freedom if you have our suit. And that's where we're trying to bring in a lot more innovation than what had happened before.
Yeah, that's a bold portfolio. If I can ask, what does a typical day look like for you as a CEO of a company pushing the boundaries of human spaceflight?
Well, we're a startup, early stages, and so you're sort of working across many verticals. So the typical day is managing different functions, right from design, engineering, finance, business development, even marketing. So we work across all these verticals, myself and my partner. So we make sure that we don't fall into the trap of just designing the product. You have to run a business, so you've got all these verticals that need equal attention. Because we're limited on resources and headcount, we need to make sure that we balance all these verticals and they're progressing to the right level. So that's the average day when we wake up. We make sure we look at the dashboards where we're tracking all the progress, and then having one-on-ones with the team members and external partners. So that's what usually makes up for most of the day. And then we go into the workshop to see how the progress is evolving.
I think balancing so much must require shifting between many hats. How do you balance technical, business, and human sides of your work?
So I got, obviously, my training in the corporate world. So I've worked at very large corporations before in Europe or North American-based ones. So one of the critical things that I picked up from my past experience was essentially managing the technical aspects, project management, and making sure people were not getting burned out and ensuring that they're still on that path of innovation. So I bring that to my work now every day. So I make sure that there is equal amount of focus on the people side. At the same time, we're monitoring our technology, researching the market, and bringing a structured approach to it, because there is a method to all kinds of madness anyways at the end of the day. So we have certain templates in place to ensure that we kind of juggle all these things and wear different hats when needed.
I think that balance sounds challenging, really challenging. I would love to hear a story of how your team overcame a specific obstacle during this process.
There have been a few obstacles. I would say a lot of times it was accessibility to certain equipment and things like that. So recently, for a major conference that was concluded, we needed to make sure that certain prototypes were ready in time, but we couldn't get our hands on basically the machinery that could do certain things. And so we had to go about different ways in producing those things, maybe looking at additive manufacturing techniques and being very creative with our thought process. So the team came together, they knew they had limited time, so we came up with some unique solutions just to make sure we met the deadlines. So those things keep happening quite often, but I think the recent one that we went through was, I think, pretty substantial for us.
That shows a lot of adaptability. I'm really curious how we are integrating everything. Moving on to, I would love to ask about different nations. And I think currently only 5 nations, Russia, USA, Germany, Japan, and China, have full-fledged human spaceflight capabilities. And India is just getting started. Why do you think it's important to expand this capability to more nations, especially in the Asia-Pacific region?
Certainly. I think this goes back to the whole conversation about air superiority. Certain nations have traditionally been very powerful in the way they produced technologies in the world of aerospace and space. And because human spaceflight is largely operated in the realm of state-sponsored development, very few countries were in that race to sort of build the next generation in that space. But over the years, what we've noticed is when you broadly look at space industry, you could say fundamental components would be like rockets, spacecrafts, or satellites, and then you have human spaceflight. A lot of nations think human spaceflight is a luxury, and they would not have to worry about it till they take care of the other two aspects. Yeah. And that's what had stopped a lot of nations from investing in human spaceflight. And we could understand the practical aspects as well. So the private industry would want to wait for human-rated rockets first to be in the market before they can invest in human spaceflight. So that's what led to a lot of nations maybe staying away from human spaceflight. But now we see a lot of positive trend in Asia Pacific. Like you mentioned, India joins the that elite club of nations right now wanting to do human spaceflight, their own human spaceflight program, space stations and all of that. But we believe you need access to more infrastructure. So more nations need to be able to train their own people. I mean, you don't have to send them into space, but you could still train your astronauts. Mm-hmm. So we believe if you can start focusing on your infrastructure, and these things take time. It's going to take decades before you have a mature ecosystem. So you have to start as early as you can. So limiting it to 5 or 6 nations would be very similar to jet engine technology. Very few nations can produce them, but the ones that have them can control the market dynamics. So nations need to put the best foot forward in that space.
Yeah, that gives great picture of systems approach. Let's zoom in on the technologies themselves and how they are reshaping future of human survival in space. Spacesuits and human spaceflight systems have long been dominated by defense primes. How can agile private players like Metakosmos disrupt and accelerate human exploration?
Yeah, so I think that's a great question that also relates to our vertical as a whole. A lot of times people talk about software or information technology being the domain where startups can make a major difference in a short span of time. But we believe this is the era where artificial intelligence and other emerging technologies can give smaller companies an edge. There are reports now that the legacy platforms have struggled over the years with innovation, showing that you don't just need big, money or deep pockets. You need the right team and the right approaches to disrupt things. So we believe 2025, this is the best time for a smaller company to sort of disrupt certain aspects that have traditionally been managed by large corporations. And we're already seeing that in the United States. There are a lot of small companies that have started in the space ecosystem that are now sort of taking over contracts from larger corporations and doing a great job. And I think a similar trend will be happening in Asia Pacific in the next 5 to 10 years.
That's a powerful vision. Now let's talk about the human side of the innovation. How do you incorporate feedback from astronauts or extreme environment specialists into your designs?
Yeah, so traditional methods like focus groups, we talk to people, these are engagements with them, dedicated engagements, or they come to our workshops, they look at what we do, they give us feedback. So everything we do in the design process is validated through human interaction. And thankfully, sometimes we ourselves could be those subjects, so we could get into these things to understand what's happening. So it's very important for us to make sure we talk to people at the edge or the users who are going to be experiencing this. And going into the depths of the ocean is an experience that only one can talk about if they've been there. So we make sure that we bring such people, diverse groups of people in that ecosystem into the room, organize interviews and get information from them that goes back into our design process.
Real-world feedback is key to pushing boundaries safely. And let's move on to human experience and training. Human spaceflight is as much about the body and mind as it is about machines. Preparing people from extreme environments is a huge part of the challenge. How do you prepare astronauts or engineers for extreme environments?
Well, I mean, from what we study, NASA has a certain way of training their astronauts, and they send that information into the public domain. Private companies had their own ways of doing things, but broadly you can say exposure to low gravity through parabolic flights or neutral buoyancy are all different mechanisms of preparing people for the experience. But lately, I think there's more specialist equipment that's being developed for people to have a crash course of sorts to make them ready for the low gravity and high G forces. Because when you have the entire process of going into space, what we know is people experience incredible G forces, right? From eventually, once you get into microgravity, to maybe 10 Gs of forces being applied to your body. So preparing a human for that spectrum is extremely critical. And there's different pathways you could go on. So starting with defense-based training programs to something that NASA would put their astronauts through, and also all these commercial avenues that people have where you could be engaging in a parabolic flight for about 60 seconds of microgravity exposure. And all of that leads to your body being exposed to those conditions. And that's how you sort of become a more relevant, I guess, person to experience those kinds of conditions.
Yeah, that preparation is really critical. And what is the most challenging human factor you had to solve for physical challenges for astronauts in space?
I would say basically it's the mobility aspect and certain areas associated with range of motion for executing certain tasks. Everyone, at least the limited group of astronauts that we've spoken to, have alluded to the fact that those are very hard points for them to work with. And bringing technologies into that domain involves working with medical doctors, fashion designers, and a whole host of other people. So it's not easy. I think that's the most challenging part that we're trying to solve for. But we're confident that we're going to make some headway in that space in the short term.
And that's a big challenge. I'm curious if you have experienced any of those environments yourself.
So obviously, I've done some diving. I've done indoor skydiving stuff that's very close to maybe skydiving. Neutral buoyancy is something that I'd like to experience at some point. And the high G forces thing, or experiencing your G-lock, as they call it, the gravity-induced loss of consciousness, is where I've been very close to certain things because I tried to get myself a pilot's license. That's when I experienced a few things. But yeah, that's the extent of my exposure to these areas. But I'd love to be involved in certain testing mechanisms like I did. I've tested the thermal systems on myself. So I got into these garments to see how it heats your body up. So there are certain aspects of the testing process that I've been in.
That must have been intense, really intense. How lessons from extreme environments on Earth translate to space, and how these experiences on Earth help prepare humans for space?
Obviously, you have to train on Earth to go into space. So you have to find the closest analogs that you could get your hands on to train. I think there's lots of similarities for deep sea operations with space. But whenever you look at people challenging their human performance in any activity for that matter, I think that would be a good analog to sort of rely on. And then you have all these other conditions that we've created, like infrastructure, where you could get access to deep sea diving or things related to high G forces and those sorts of things. I think people can expose themselves to these methods before they actually start preparing for human spaceflight. But there's also a lot that you could learn from maybe going to Antarctica or, being in the parabolic flights or even in a hyperbaric chamber and these sorts of things. So anytime you're pushing the limits of your body, I think that's a very good experience to be in before you embark on your journey to space.
Yeah, I see space exploration is moving faster than ever. Let's talk about the future, both for the industry and also for Metakosmos. Where do you see human spaceflight in the next 5 to 10 years?
As we all know, the International Space Station is being decommissioned in 2030. There are a lot of private companies trying to build private space stations. And I see a lot of opportunity in those ecosystems for human spaceflight to thrive. I also believe that we're going to have a lot more private spacewalks. So you will have commercial astronauts who might be engaging in extravehicular activity, and that would create a demand for training more astronauts here on Earth. And you could go down the route of commercial pilot licensing industry because, I don't know, there's maybe 5,000 pilot training schools worldwide in comparison to the 5 or 6 places where you could actually train astronauts. So I believe in the next 5 or 10 years, you're going to have more avenues to train, and then at the same time, more pathways to go to space as well and make it more affordable. So it's certainly very expensive now, but through time, if you could start sending more people, like we discussed, the more of something you do, the lesser it should cost us. So the hope is that it's going to cost a lot less than what it is right now.
I think the next decade of human space flight will definitely be defined by companies like yours. So how does Metakosmos fit into the evolving space ecosystem?
Yep. So when you look at the entire ecosystem, obviously you've got the rockets, and then you've got satellites and human spaceflight. We'd love to play a pivotal role in the human spaceflight ecosystem, working with the space agencies or commercial primes where we could support them with these specialist tools that we're building. We could also set some standards in the industry because we're doing very unique work in certain areas. We believe we can lead certain pathways in certain areas that are relatively unexplored. And I also see a lot of opportunity for producing a lot of suit engineers in the market. So a lot of work we do right now could be captured as a program for training the future suit engineers into the market. So if you have a healthy ecosystem, then you will have people who could build suits, who could use them, and then use vehicles to go up into space. So I think we can play a pivotal role in that ecosystem.
It's exciting. So what are Metakosmos' key milestones and goals for the near future?
So what we'd love to do is obviously start testing the suit. And we are making some adjustments to our backend method and process so we could cut across as many testing programs that we could get our hands on to make the suit qualified. And also, I think in the world of space, you need to fly a part of your equipment to microgravity to get some communication set up, because in the world of space, as you might know, there's no 2.0. Your 1.0 should work. So your prototypes should also work. So the next big milestone we're aiming for is to ensure our prototypes get it right. And then that will mean a few attempts for sure, but we'd love to make sure that our prototypes are capable enough of helping us move the needle on the training and certification process.
Yeah, those are ambitious. What advice would you give to young engineers, space enthusiasts, or aspiring CEOs?
Well, I would say it would be a challenging ride, so you have to be prepared for facing challenges. And one thing that I got as an advice early on when I started was there's never going to be enough money, time, or resources. Everyone's going to be battling for these 3 categories. So you have to make sure that you can work with limited resources to achieve exponential results. So that's going to be something that I would definitely advise people. So do not expect to get all the funding that you're seeking or all the human resources you're looking for and all the time that you want in the world. You should be focused on delivering things with limited resources.
Yeah, that's a great advice. And finally, how do you personally stay motivated and inspired in such a high-pressure, high-stakes field?
Well, at the moment, unfortunately, I don't get much of a downtime to check out. But whenever I get a chance to attend events, I use that time to sort of like sit back and observe the industry, talk to different groups, and learn from them. And recently we were at the ISC, and it was fascinating to literally see 40 plus space agencies around the globe in Sydney, and talking to different suppliers and large corporations as well, and how they've evolved. I think that is something that helps us get some perspective on things, because, you know, when you're in the thing, you may not be able to work on your business from the outside, but those are some times when I step back and take an objective view of what's happening and how we're kind of like progressing compared to others in the industry.
Yeah, that's powerful. That's really powerful. Let's wrap up things with a fun segment. If you could live on any planet, or moon for a month, which would you choose and why?
Well, Jupiter, for some reason. I think it's the largest planet. I've always been fascinated by the scale and the size of the planet. And I would be watching these videos on YouTube about what if you land on Jupiter. I think it'll be fascinating if it's possible to one, go there and sort of like experience Jupiter's atmosphere and everything that happens there.
Yeah, it sounds adventurous. What's one piece of tech you wish existed to make space travel easier or more fun?
One piece of tech, for sure, I think would be commercial spacesuits. I wish I had a suit of my own that I could use with a SpaceX vehicle so I could just get there and say, yeah, I could take a trip. But yeah, that's what we're working on. I wish that was there.
Yeah, that would be incredible. Outside of space, I'm curious about you personally. When you're not building systems for space, how do you relax or recharge?
Movies. I love graphic novels. I watch a lot of sci-fi work that people do. I love the entire behind-the-scenes process of how filmmaking is done. So I look at how people bring together complex ideas into a very simple format in an hour-long, video or maybe 2 hours film. So that I'm on the internet following trends in other industries that have nothing to do with our industry. So we look up on things related to maybe medical sciences or something related to food production. So that's how I sort of, unwind when I'm not focusing on our core work.
That's refreshing to hear. So do you also have any quirky or space-related hobbies or rituals?
I think maybe not space-related, but I'd love to try out more of that indoor skydiving thing. I think it's a fun activity that you could do with your family as well. It's less risky compared to the real dive. So whenever I get a chance, I'd like to go into those chambers and float for a few minutes. And I think that's a great way to experience some form of flotation.
Yeah, that's fun note to end on.
Thank you. Thank you for having me.